Now squaring and adding these 3 and 4. So and squaring means here we will write a plus b. This is cos phi whole square plus this is b square sin square phi is equal to, this is r square taken common, I will write it directly, cos square theta plus sin square theta, that comes out to be 1 by the formula. And now expanding it, this will become a square plus b square cos square phi plus 2ab cos phi plus b square sin square phi is equal to r square. So now this b square sin square phi and this b square cos square phi taken one side, a square plus b square taken common, this is a square plus b square cos square phi plus sin square phi plus 2ab cos phi is equal to r square. Okay, now this factor is equal to 1, so we'll write here r square is equal to a square plus b square plus 2ab cos phi. So this is the magnitude of the resultant wave. Now it can be written as r is equal to root of a square plus b square plus 2ab cos phi. Okay, now we know that intensity is directly proportional to square of the amplitude. So for the first wave, intensity I1 is equal to Ka square. For second wave, I2 is equal to Kb square, right? And for the resultant wave, IR is equal to Kr square. Now this is Kr square, so we will multiply this expression by K both sides. So we will be having K a square plus b square plus 2ab cos of phi. Okay, now this Ka square is I1, Kb square is equal to I2, and this now when it is multiplied inside, so this will become Kab. Okay, Kab. Now a can be calculated by root of I1 and b can be calculated as root of I2. So we'll write here this is equal to IR is equal to I1 plus I2 plus 2 root of I1 I2 cos of phi. So this is the expression for the resultant intensity. Now from here we can get the conditions for constructive and destructive interference. For constructive interference means the interference redistribution of energy where the intensity is maximum. This expression, this cos phi should be maximum. Now cos phi can be maximum if this phi is cos phi is maximum, which is equal to plus 1. Okay, this is plus 1. Now phi is 1 when it is phi angle is either 0, 2 pi, 4 pi and so on. So we can write phi is equal to 2n pi, where n is equal to 0, 1, 2, 3, so on, right? And correspondingly, if x is the path difference between two consecutive waves, then x is equal to lambda by 2 pi into phi. So accordingly, lambda by 2 pi and phi is 2n pi. So accordingly, this 2 is cancel out, pi is cancel out, and means here n lambda. So it means the path difference will be x is equal to n lambda. So we can say that the condition for constructive interference is 0, 2 pi, 4 pi, and means whenever the path difference is lambda, 2 lambda, 3 lambda, so in that case we will get the maxima in the interference pattern. Similarly, we can get the condition for destructive interference. Okay, now what is the condition for destructive interference? Means this cos phi should be minimum. Cos phi is minimum, it means that should be equal to negative of 1. Now that will be minus 1 when phi is equal to pi, 3 pi, 5 pi and so on. or we can say that phi is equal to 2n minus 1 pi by pi. Okay, means that when n is equal to 1, when n is equal to then 1, phi is equal to pi. When n is equal to 2, phi is equal to 3 pi. When n is equal to 3, phi is equal to 3 pi, and so on. So accordingly, the path difference x is equal to lambda by 2 pi into 2n minus 1 into pi. So pi to pi is cancel out, and we will be having 2n minus 1 lambda by 2. So what will be the position when n is equal to 1? X is equal to lambda by 2. Then n is equal to 2, x is equal to 3 lambda by 2, 5 lambda by 2, and so on. Means you will get the minimum at the positions lambda by 2, 3 lambda by 2, and 5 lambda by 2 respectively.